My dear students, today I am going to discuss a very important chapter of maths called sets or theory of sets. Now this chapter is included in different board exams for classes 10 and 11. So I hope students of 10 and 11 will be benefited by today's discussion. Now first of all, let us define sets. A set is a collection of well-defined objects. So this is the shortest definition of set. So what is a set? A set is a collection of well-defined objects. Now well-defined. For example, suppose this one. Now these five are vowels. So they have a common property. They are vowels and they are well defined. So there is no controversy, no doubt about these five letters A, E, I, O, U. So they are vowels. So this is a set of vowels. So well defined. But suppose set of intelligent students. Say collection of intelligent students. Now this is not a set, so we will not call it set. We will simply call it collection. So collection of intelligent students. Now you cannot call this group a set because who is intelligent, who is not intelligent, so that is a matter of controversy. So there are different people will have different opinion about who is intelligent student in your class. So therefore this is not well defined. Similarly, say collection of beautiful people. So that is also not well defined. Usually these adjectives, intelligent, lovely, tall students, tall boys, short boys. So those adjectives actually they give rise to what? Not well defined, and therefore that group cannot be called a set. So it will be simply called a collection. You cannot say set of tall students in class 10 or class 11. So you will say collection of tall boys, tall students. Now who is tall, who is short, that is a matter of controversy. Different people have different opinion, all right? So remember, set is a collection of well-defined objects. So well-defined. Similarly, suppose this one. Say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These 10 are digits. So this is a set of digits, set of all the digits. This is a set of all the vowels in English alphabet. This is the set of all the digits in decimal system. So these are well-defined objects, therefore they are sets. Now when you write a set, so there are some rules, like we have to give a name. Suppose this we call A, this we call B. So A is a set of vowels. That is how we will call it. A is a set of vowels. B is a set of the digits in the decimal system. And in order to write set, you will use these braces. So you see these braces must be used. You cannot use any other type of brackets. So this is, you can say, chain bracket, second bracket, isn't it? So we will use these braces. So we use braces and then commas. So in between any two members, commas. Now these members are called elements. So remember these terms, elements. So this set A has 5 elements, A, E, I, O, U. This B set has 10 elements. So these members are called elements, and set is written using braces and commas. And a set must be given a name, and these names are usually capital letters. capital A, capital B, capital P, capital Q, like that. I follow? Now, this is set A, and A is an element of this set A. So we write this symbol. A belongs to A. So this symbol, this is epsilon. This is the Greek letter epsilon. All right. So using this epsilon means belongs to. A belongs to this set A. That way, suppose 0. 0 belongs to the set B. So this symbol, which is a Greek letter epsilon. So this means belongs to. So A belongs to the set A. 0 belongs to the set B. That means 0 is an element of B. A is an element of A. That way, suppose this U belongs to A. All right. That was number 4. 4 belongs to B. 4 is an element of set B. Now, say M. Now, M does not belong to A. See, A does not contain M. M is not an element of A. So we write M does not belong to A. This is a symbol meaning belongs to. So this means belongs to, and this means doesn't belong to. That way, suppose here, say 10. 10 does not belong to set B. All right. So that way. Okay. The next, a set is written in different forms. So there are two forms, roster form and set builder form. Actually, the roster form I already showed you. So that set, say A is a set of the 5 vowels. Now this is roster form. This form is called roster form. Roster or tabular form. So I have written this set in what form? Roster form or tabular form. In this form, we write each and every element. There are 5 elements. We write all the elements using commas and of course braces. All right. That way, that second one which I wrote before, that is B, that is 0, 1, 2, etc. up to what? So this is also a roster form or tabular form. So I have shown all the 10 digits. So this is a set of digits. So all the 10 digits using commas between any two elements. So this is called roster form. All right. Now in this roster form, there is a very important point. Suppose you want to write the set of the letters in the word, suppose science. It's a set of all the letters in the word science. Now in roster form, we'll write this way. Suppose we call it P. We call it P. Now see the letters S, C, I, E, N. S, C, I, E, N. Now we will not write C, E again because C, E already there. So there should not be any repetition. So there should not be any repetition of any element. All right. Now in science, in this word science, SCIEN, CE. Now CE are already there. So we will not write CE again because they are already present there. So this is the set of the letters in the word science. Although the word science has 1, 2, 3, 4, 5, 6, 7 letters, but we have written only 5 letters without repeating C and E. So in roster form, when you write, no element should be repeated. All right. Similarly, suppose Q. Q is a set of the letters. Suppose loyal. Say alloy. ALLOY. So you want to write the set of all the letters in the word alloy. So how will you write? A-L-O-Y. So there are two L's. So without repetition, we will write only one L. A-L-O-Y. You follow? So in this roster form, the elements, no elements should be repeated. Okay. So this is called roster form. The next form is builder form. This is roster or tabular form. The next form is called set builder form. In builder form, we try to find some common property of the elements. All right. Now this is set builder form. The second is set builder form. Set builder form. Now suppose that set of vowels. Now this is in roster form. Now if you want to write in this form, set builder form, what you will do? You will try to find some common properties of these elements. Now these elements have one common property. What is that property? Each of them is a vowel. So that is a common property. So in order to write in set builder form, we must find some common property of the elements or members of the group, members of the collection. So what is the common property of these 5 letters? Each of them is a vowel. So we will write in set builder form this way. X such that, now this is a symbol colon, isn't it? These 2 dots, this is called colon. So I think you know semicolon, colon. So this is colon. So this colon means such that. This means such that. So A is a set of X such that X is a vowel. So this is the set of vowels in builder form. So common property we have found, each of them is a vowel. So this is how we write. So A is a set of X such that X is a vowel. All right. That way the other set, suppose the set of digits, how will you write that set B, set of digits? This way. Now you can use X, Y, Z, mainly X is used, but you can also use Y and Z. So Y such that, this means such that Y is a digit. So this is in roster form, this is in builder form. So how will you read it? So A is a set of X such that X is a vowel, or all X are vowels. Similarly, that set of digits, those 10 digits 0 to 9, how will you, that was in roster form I showed you. In builder form it will be B is a set of Y such that Y is a digit, or all Y's are digits, all the Y are digits, that way. I follow. So in roster form or in roster or tabular form, we use commas and we write each and every element. But in builder form, we do not write the elements. We write their common property. Common property, like this, each of them is a vowel. Like those 0 to 9, each of them is a digit. Follow? So this is in builder form. Okay. Okay, now suppose one question. Say one question, let us see. Say write set P in roster form. So write this set P. So the set P is this, X such that X belongs to capital N and X is less than equal to 5 and greater than equal to 0. Now this set is written in what form? Builder form. When you use this X and colon, this is in what form? Builder form. Now this set will contain those elements. Now n means natural number. So n is the set of natural numbers, z is the set of integers. So those letters I followed. So n is a set of natural number. Now x belongs to n, that means x is a natural number. So this set contains natural number. Again, which natural number? The natural numbers which are greater than 0 but less than equal to 5. So two qualifications are given, two properties are given of the elements. The elements which we are going to write in this set in roster form have two properties. Those two properties are mentioned. So one property is this one, the element is less than equal to 5. It should be 5 or less, but it should be greater than 0. And the element that you are going to write must belong to n. That means it must be a natural number. All right. So this is in builder form. So what is the answer in? Write this in roster form. In roster form. So in roster form, what is the answer? So this is a question, and what is the answer? So let us see P. Okay. Now, what are the natural numbers? What are the natural numbers greater than 0 or less than equal to 5? So simply 1, 2, 3, 4, 5. You see, this is in roster form. See, these two conditions are satisfied. Now that element belongs to n. That means it is a natural number. N is a set of natural number. Now are not these natural numbers? So this condition is satisfied. Now this condition greater than 0. See, each of them is greater than 0, and less than or equal to 5. See, up to 5. So this set P is in builder form, and the same set P in what form? Roster form. Okay. All right. There is another question. This set, write set Q. This is given in roster form. You have to write this in builder form. This set, write this set Q. Q is given this x such that x belongs to z, and x square equal to 25. This is also given in builder form. See, this set Q is given in builder form. You have to write in roster form. In roster form. Okay. So this is in builder form. Again, two conditions are given. Two common properties of the elements are given. What is that? That element should belong to z. Z is a set of integers. So z means the set of integers. So x is an integers. The element that you are going to write in roster form should be an integer, and the element should be such that square of that element is 25. All right. So this is you have to write in roster form. So what will be the answer in roster form? So Q. Now you see x square equal to 5. So solve it. X square equal to 25. That means x equal to root over 25. Now root over 25 is plus minus 5. So we got two elements. So there will be two elements. So it will have two elements, plus 5 and minus 5. So plus 5 and minus 5. So from this what we get? Value of x, plus 5 and minus 5. So plus 5 and minus 5 will be the two elements. Now let us see if they satisfy this condition. Now they should belong to z. That means they should be integer. Yes, 5 is an integer, minus 5 is an integer. All right. So you see both the conditions are satisfied. So these two elements have two common properties. One common property is that they are integers. They belong to the set of integers. And the second common property is that yes, square of each is 25. Square of plus 5 is 25. Square of minus 5 also 25. So like this you see. So this was in builder form. We wrote in roster form. This is in builder form. We wrote in what? Roster form. Is it clear? Okay. Yes. Now let us see next. What are the types of sets? There are different types of sets. All right. So let us see different types of sets. Okay. So first of all, the empty set or null set. So first let us see that the different types of set. Empty set. Empty set, it is also called null set, or it is also called void set. Empty or null or NULL, null or void set. So empty set, that means it has no element. It has no element. So this is the set. You see, suppose now empty set symbol is the Greek letter phi. So this is Greek letter phi. So this is the symbol of empty set or null set or void set. So this is a set with no element. This one. So empty. So null set is, how will you define null set? A set which has no element. Which has no element. That means number of element 0. You followed? Now set of vowels have 5 elements. So number of set of vowels is what? 5. Suppose A is a set of vowels. So it has how many elements? 5. So we write this way, NA5. This is the way to write to mean what? Number of elements. Number of elements of set of vowels is 5. But number of element of null set is 0. So number of elements of null set is what? 0. No element. All right. So this is the symbol of this or this. Both are symbols of what? Empty set or null set or void set. So empty set or null set is one which has no element. Okay. For example, suppose this set. Suppose P is a set of X such that X belongs to N, and X is less than 2 but greater than 1. Yes, now see. This is going to be a null set. I have shown in builder form. Now in roster form it will be what? It will be simply a null set. There will be no element. Why no element? You see. Now the element that you are going to write here must satisfy these two conditions. It must be greater than 1 and less than 2. That means lying between 1 and 2. And it must be a natural number. It must belong to the set of natural number. So the element you are going to write here must be a natural number, and it must be less than 2 and greater than 1. Now is there any natural number less than 2 and greater than 1? No. Between 1 and 2 there are only fractions, no natural number. So satisfying these two conditions, there is no element. So it is a null set. So this null set is what? I have written in builder form, and in roster form this one. This is roster form, but then there will be no element. Okay. All right. So that way there are different types of what? Null set. Okay. So this is null set. This is the first type of set. Then second type is what? Finite set. Finite set. Now finite set has a definite number of elements. So a set which has definite number of elements. Definite number of elements. A set which has definite number of elements is called a finite set. So set of vowels. Set of vowels is a finite set because it has just 5 elements, neither more than 5 nor less than 5. Now set of digits is a finite set because there are a definite number, 10 elements. All right. Set of the letters of English alphabet. So it is a finite set because there are just 26 letters, neither more nor less. So number is definite, 26. Vowels, number is definite, 5. So definite number of elements. So that is a finite set. All right. Okay. Now infinite set. Just opposite to this infinite set. So I think you have understood infinite, that is no definite number of elements. Finite set is a set having definite number of elements. An infinite set is a set having infinite number of elements. For example, say this one, set of natural numbers 1, 2, 3, 4, 5. That is the counting numbers, set of natural numbers. It is also called set of counting numbers. So etc. It goes on and on and on. Starting from 1, it goes on endlessly. So there is no end to it. So this is a set what? Infinite set, because it has infinite number of elements. So a finite set is a set which has definite number of elements, like the set of vowels, set of digits, say set of all the natural numbers from 1 to 100, from 1 to 100. So that set will be a finite set. But set of natural number will be infinite set. Set of integers will be infinite set. Set of real numbers will be infinite set, like that. Okay. Now this one, set of concentric circles. Set of concentric circles. What do you think? It is an infinite or finite set. Set of concentric circles. Set of concentric circles will be infinite set or finite set. It is infinite set, isn't it? Because suppose this is a center. This is a center of a circle. This is the first circle. This is a second circle. All these are concentric circles. You can go on and on and on. So there is no end to it. So set of concentric circles will be what? Set of concentric circles will be what? Infinite set. All right. Okay. Now what about the set of hairs or on your head? Yes, think. What is the set of hairs on your head? The set of all the hairs on your head. So what do you think? This is infinite or finite set? So this is definitely a finite set. This is a finite set. Now it may be difficult to count. There may be say 1 million hair on your head. All right, may be difficult to count, but we can count and finish it. It is difficult to count, but not impossible. There are a definite number of hair on your head. So the set of all hairs on your head is what? A finite set. Similarly, set of stars, very difficult to count, but then it is a finite set because there is a definite number of sets at a particular moment. Now you can say sets are dying, sets are reborn. Yeah, that is true. But in a certain moment of time, the number is definite. So set of stars at a particular moment is what? Finite set. Okay. Then null set is also called finite set. So null set is finite set. Because it has a definite number. The number of null set is what? 0. It has a definite number of elements. It has a definite number of elements. How many elements? 0 element. Now 0 is a definite number. So null set is a finite set. Why null set is a finite set? Because the number of elements in a null set is 0, and 0 is a definite number. All right. Maybe 0 doesn't mean no element. It means there is no element, but it is a definite number. So definite number of element in null set. Therefore, it is called finite set. Okay. All right. Then next type of set is what? Number 4, equal set or equivalent set. Number 4, equal or equivalent set. Equal set. Equal, and some books write equivalent. All right. So equivalent sets. Now, equal or equivalent set, that is, if two sets have exactly same elements, then they are called equivalent set. For example, suppose this set A, suppose it has 3 elements A, B, C, and set B has the same 3 elements, suppose B, A, C. Now here note another very important point. Now when you write a set, the order is not important. Now the set of vowels, say we wrote A, E, I, O, U, but you can write this way also. Set of vowels you can write you see, the order is not important. This is also set of vowels because all the vowels are there, A, E, I, O, U. When you write the elements in the collection, when you write the elements in a particular set, the order is not important, not relevant. You can write in any order. Now, this is a set containing 3 letters A, B, C. This is a set containing same 3 letters A, B, C. The order is different, but that is irrelevant. That doesn't matter, immaterial. You follow? So, these two are equal sets. So, we will write what? A equal to B. Why A equal to B? Because they have exactly the same elements. Alright. That is how suppose these two sets. Now suppose set of letters in the word God, and set of letters in the word good. So these two are equal sets, you see. The set of letters in the word God and set of letters in the word good. So these two sets are equal sets. Why? Suppose the first set is set of letters in the word God. So Z, O, D. Alright. Then set of letters in the word good. Suppose that is Q. So good. Z, O, again D, because in the beginning I told you that is there should not be any repetition. So there are 2 O's, but we will write only one. So you see, set of letters in the word God, Z-O-D, and set of letters in the word good also, Z-O-D. So these two are exactly same. Therefore P equal to Q. Alright. That way, set of letters in the word, suppose alloy and loyal. Set of letters in these two words are same because the first one is what? The first one alloy. So what will be the set? A, L, O, Y. Suppose this is a set A. A, L, O, Y without repetition, isn't it? Then this set, loyal, suppose we call it B. So what is loyal? L, O, Y, L, O, Y, A. L, O, Y, A. So we will not write L again because no repetition. So L, O, Y, A. And then here alloy, A, L, O, Y. Yes, the comma. Now see, these two are exactly same. They have got exactly the same elements. A, L, O, Y, A, L, O, Y. So therefore, what is our conclusion? Therefore, A equal to B. Okay, follow? So A and B are equal sets. So that is the meaning of equal or equivalent sets. That means two sets having exactly the same elements without repetition, of course. All right. Okay, so today I discussed up to this point. So next time I will continue from here. We'll discuss sets, subsets, then addition, subtraction of sets. Okay. Union, then Venn diagram and all that. So I'll continue from here. Okay, so today up to this point. So thank you.